Okay, this is Introduction to Statistical Learning. We're in Chapter 12, which is all about unsupervised learning methods. And we're on question number 3. And here we are going to perform k-means clustering, and we're going to do it manually rather than using an inbuilt function in our software. And we'll assign 2 different clusters to 6 different observations based on 2 variables for each observation, and all of that data is reproduced right here. And of course we'll go through parts A through F in order so we don't need to memorize the questions. First thing we'll do is to recreate the data in R. So that's what I've done here. So I have observations A through F and then their x1 and x2 coordinates or values, and we will treat these as coordinates and then plot them, and that's what we'll do here in part A. Okay, so part A we're just going to plot these. There we have them. Okay, and so we see 2 visually distinct clusters here, and so then the question is how do we get, how do we algorithmically find these clusters, right, rather than just having to rely on our eyeballs. Okay? And that's what the first few parts of this question will kind of walk us through. So the first thing that we're going to do is randomly assign a label to each observation, right? So each of these observations is going to get group 1 or group 2 randomly assigned. And so here we're using the sample function to do that. So we're going to sample 1 or 2, okay, randomly. And so each row is going to get 1 or 2. And here I'm calling this a data frame so that we could easily add to it. And I'm calling this 0 for the 0th assignment, right? This is just a random initialization. So this just gets called 0 for that reason. You don't have to do it that way. We'll see what that looks like. So again, this was a random initialization, and this was the random assignments of our clusters, right? So we have 2 clusters, red and black, and in the red cluster we have A and D, and then all the rest are in cluster 2. Now, of course, that doesn't look like a very good cluster, and it's not, and that's why we will iterate. We'll go through some steps and maybe iterate those steps depending on how quickly this all stabilizes. But the first thing that we're going to do in part C to take a step in that direction is to find the centroid for each cluster, right? So for the red cluster, we imagine, well, the centroids probably are both somewhere in this no man's land for both of these, okay? But let's compute the centroids for these. So we're just going to, so for cluster 1, we're going to take our data that have been assigned 1 by the clusters, okay, and then we're going to get their x1 and x2 coordinates, and then take the column means for those, and then similarly for grouping 2. And we can see what that looks like here. So cluster 1 has coordinate 3, 2.5, and for cluster 2 it's 2.75 and 2.25, but we'll just look and see what that looks like. And there's the centroids for the 2. Okay, so this is an interesting one because the centroids are so close, and so this might actually take more than a few steps to converge. Okay, so next we're going to assign each observation to the centroid that it's closest to, right? So in other words, we're going to, so say we're taking B here, we're going to assign it either red or black depending on whether it's closer to the black centroid or the red centroid. Okay, and so to do that, we find the distance. All that is here. You can look at the code for yourself, but we'll just take the distance to both of these dots, figure out which one it's closest to, and then call that its new assignment here. Okay, so we'll do that. Okay, so just to see how this is working, so for observation A, its distance to C1 is apparently 6.25, and then for centroid 2 it's 6.125, right? So it's marginally closer to 2. I think black is 2. Is that right? I'm not sure, but that will all be resolved here, and then we go through each of these. Okay, so let's see what this looks like here. Okay, so here's our new assignment. All right, and we have it did a pretty good job so we have one cluster A, B, C, F, and then D, E, right? Now we probably need to iterate this again, and if we did it again, you can imagine what's going to happen. We're going to have a red centroid right between D and E, and then we're going to have a centroid A, B, C, F that's going to be somewhere right here. Not easy to say, actually. It's probably going to be closer to the ABC cluster. And, of course, D and E will be assigned to the red cluster, and F will also be assigned to that red cluster because it will be closer to that centroid. But in order to do that, we would have to, redo all of that code. And most of the time when you run this code, it takes just one step and it finishes. But that's okay. We're just going to leave that here. If you were to rerun this with a different random initialization, you would get, you would get a different configuration, and it would likely converge in one step. But in part E, we're going to repeat this until it does stabilize. Now, again, in this particular example, we could just repeat the code and walk it one more step. But instead, what I've done is I've just created a loop to solve the problem, not taking into account what happened here in our previous work. So I've just created a loop here, and I'm not going to walk through it, but you certainly can. But it's basically the exact same code, just wrapped up into a loop. Okay, so I'm going to run that. Okay, so in this particular case, we have it goes 3 iterations before we actually stabilize. So the loop runs until 2 iterations are identical, right? So you see iterations 2 and 3 are identical here. So that's how the loop knows to stop. That means we've reached a stable solution. And we get the final centroids as well as the clustering here. But we can plot all of that, and there's our final clustering. Okay. And again, I believe that this is the exact same configuration that we started with. I'm not really sure. I'm not sure if this has the same initialization. I don't think that it does. But anyway, we converge to this solution almost inevitably when we iterate that process.